Great people, welcome to NameTech channel. My name is Nehemiah and I'm so happy to have you on board. This is lesson 8 on Scipy. We are going to talk about Scipy interpolation. But then before we begin, please take a minute, subscribe, like and share the video to your friends if you have not done so. And to the returning subscribers, thank you very much for your continuous support. Now guys, basically let's begin by first understanding what is interpolation. Now basically interpolation is a method for generating points between given points. And it has many usage. Like in machine learning, we often deal with missing data in a data set. So interpolation is often used to substitute those values. And this method of filling values is called imputation. And apart from imputation, interpolation is often used where we need to smooth the discrete points in a data set. So guys, how do we implement interpolation in Scipy? Now basically Scipy provides us with a module called scipy.interpolate, which has many functions to deal with the interpolation. And guys, let's begin by first tackling one-dimensional interpolation. And the function in the P1D is used to interpolate a distribution with one variable, and it takes x and y points and returns a callable function that can be called with the new x and returns corresponding y. So guys, let me show you an example how to interpolate values perhaps from a range of 2.1 all the way to 2.9. Before anything, you must draw what? You must import the modules. We are importing what? From scipy.interpolate. From scipy.interpolate, we are going to import what? Import in the P1D, and then also we are going to import the numpy. So import a numpy is what? Is np alias. You can use another alias name, np alias. And then also let's now create the x. So for x, let me assign it to np.arrange. A range of what? Over 10. A range of 10. Then for y's, let me assign it to what? Let me assign it to 2 times what? 2 times x, 2 times x, and then plus 1. 2 times x plus 1. And then here let me use a variable name called interp underscore function. Interpolate function. Basically you can use another function, actually variable name, but then let me use that one. Then assign it to in the let me assign it to in the P1D, and then let me pass in what? And let me pass in x. Let me pass in what? Let me pass in x and also the y's. And then what I do, let me create the new array. Perhaps let me call it a. You can give it any other variable name, but then let me call it a, and then let me assign it to let me pass in that function in the variable in the p underscore function. In the p underscore function, then what I do, let me add this argument inside these rounded brackets, and then let me say np for numpy arrange. Numpy arrange. Then I'm gonna pass in what? 2.1 perhaps 3, and then the other one let me use perhaps 0.1. and then what I do guys, here let me say what? Print. Let me say print, and then I'm gonna pass in the new array, which is then guys, what I do, let me run the codes, and then guys, basically this is how you can do it. This is how you can obtain the results here. And then as you can see, the new x should be in the same range as of the old x, meaning that we can't call the interpolate function with values higher than 10 or less than 0. So guys, let me talk about plain interpolation. Now guys, basically in one-dimensional interpolation, the points are fitted for a single curve, whereas in this as plain interpolation, the points are fitted against the piecewise function defined with the polynomials called as planes. Now guys, basically the invariant plane function takes x and y's and produce a callable function of a function that can be called with the new x. Now guys, basically the piecewise function is a function that has different definition for different ranges. So let me show you guys an example how to find the invariant plane interpolation perhaps for a range of 2.1 all the way to 2.9 of an nonlinear point. Like so guys, basically here the module, let me just change from inter p1d, then I add in what basically uni should be univariate spline, univariate spline. I think the spelling is very correct. Let me copy the name, let me copy, and then what I do, let me change where else here in the p1d, let me change it to invariant plane, and then where else should I change the, I think it's correct now. Then what I do, let me run the codes, and then guys, basically that's how you can find what the invariant plane of interpolation between the range of 2.1 all the way to 2.9. So guys, let me talk about the interpolation with radial, and let's begin with basis function. Now basically a radial basis function is a function that is defined corresponding to a fixed reference point, and basically RBF function also takes x and y's as arguments and produces a callable function that can be called with the new x. So let me show you guys an example how to interpolate x and y's using the RBF and find the values for a range of perhaps 2.1 all the way to 2.9. So in that case guys, I'm just changing the module here from invariant plane to R. Remember it begins with a capital RBF. Where else should I change? And perhaps here the values, let me change it to perhaps let me use a different word, like let me just say plus numpy, actually np sign, the sign of what, the sign of x, actually the x sign of x, and then plus what, plus 1, and then here also let me change the module, the function to what, to RB, actually RBF. Remember it begins with the capital and then the rest are small letters. And then what I do, let me run the codes. And so guys, basically this is how you can do it. This is how you can interpolate these x and y's and do it and find the values for the range of 2.1 to 2.9. So guys, basically this is all about Scipy interpolation, and this is what I wanted to show you. Please now consider subscribing, share this video to your friend, and also like the video. Until next time, this is Nehemiah. Goodbye.